Alright, welcome to a video on surface area of prisms and cylinders. Now, I made a mistake the first time I recorded this video, and that mistake is good news for you, because that was over an 11-minute video, and now the video is going to be shorter, because I decided to change some things. So, just because you make a mistake doesn't mean things are bad. You can always learn from your mistakes, learn from your failures, and do something better the next time. So let's get into this. So there's two ways we're going to look at the prism surface area. We're going to use the formula, which is surface area equals 2 times area base plus perimeter times the height. And we can shorten it so that it says surface area equals 2 capital B plus perimeter times capital H for height. And then we have the other way, which is we're going to break the solid into the individual shapes and then find the area of each. Now, whichever way you like doing this, that's up to you. I'm going to show you both ways, and then you can decide which one is best for you. So, on the left, we're going to do the formula. Now, with a prism, when we're talking about the base, it's all about the base. Yeah, pop culture reference. So, if all the shapes are rectangles, anything can be the base. If there's a shape that's other than a rectangle, then that's the base, plain and simple. So on the left, we can pick any rectangle. On the right, the base has to be the hexagon. So on the left, let's just pick this to be our base. And it's always good to find your base first. So there's our base, which means that this is our height. That 15 connects the bases, and the height is the thing that connects your bases together. So we're going to do 2 times area base plus perimeter times height. And I always suggest that once you identify the base, you replace that with the formula. So the area of a rectangle is base times height. And please note that these are lowercase b and a lowercase h. Whenever we're talking about a 2D, we always do lower cases. Plus the perimeter of the base times the height. So our base and height of our base, the base of our base, yeah, a little confusing at times. 4 times 10 plus the perimeter would be 28 times the height, which would be 15. So we type this in the calculator, and we're going to round this to the nearest hundredth. This whole video, we're going to round it to the nearest hundredth. We don't need to this time, though, because we get 500. And then it's feet squared. This is an area, so it's still feet squared. So on the right here, we have a hexagonal prism. So we're going to do this by breaking it up. Now, because this is a regular polygon, that helps us. It means that all the rectangles on the side here are going to be equal. So we have a hexagon, that's our base, and we have 2 of them. So we can multiply that by 2 and add that to our rectangles. Now all of our rectangles are the same dimensions, they're all 4 by 10. And I got that 4 by 10 by looking here. That makes up our rectangle. And it's 4 by 10 because it's a regular polygon. All the sides are 4 inches. Now, we can go ahead and multiply this by 6 because there's 6 rectangles. If you want to draw out 6 rectangles and put the 4 by 10 there and find individual areas, go for it. But I'm not going to do that because I'm lazy and I want to get it done. And I want to use my thinking a little bit more than just writing everything out. If you want to do it, go for it. If that helps you, do it. But I'm not going to do it here. So let's type in our area formulas, or write in our area formulas. So 1/2 times apothem times perimeter plus 6 times the base times the height. So we get 2 times 1/2 times the apothem of our hexagon, which is 3, times the perimeter, which is 24, plus 6 times the base and the height our rectangles. So we type this into our calculator, and be very careful when you're typing this in. Calculator errors will get you. Normally people will mess this part up. The addition part, same thing on the other side, they'll mess up that addition. But we get 312 inches squared. So there's our two methods. So I want you to go ahead right now and use either method here. I'll pause the video and I'll actually do both methods for you so you can have a look at it. So go ahead, pause the video and work through those now. Alright, so here are the two solutions. You see we got the same answer, which is good. We should have. So go ahead, whichever way you did it, check your work with mine. If there's something odd the way I did it between you and you just want to make sure it's right, go ahead, ask me. We'll talk it over. And now we're going to move on to surface area of cylinders. So we're just going to do the formula. The reason we're just going to do the formula is because all cylinders have the same base. The base is a circle. So it's still that surface area equals 2 times area base, but now we're going to add the circumference times the height. So because we don't have a perimeter with a circle, it's circumference, we write in the C there. Now the nice thing is that since all the bases are a circle, all the bases are going to have the same area and circumference formula. So we can actually take those formulas and plug them right in here. So we have one formula that'll say surface area equals 2 pi r squared plus 2 pi r times the height. So we don't even have to worry about different formulas. It's just we plug in r and the height and we're good to go. So I'm going to do the example here on the left and you do the one on the right. So I'm going to go ahead and go, since I already have the formula up there. So the surface area is going to equal 2 times pi times the radius squared. So we know our radius, it's 4. Plus 2 times pi times the radius times the height. And the height connects your two circles, and that'd be 7. So we do this, and we get 2 times pi. We get 276.460. We're rounding to the hundredths, so we get 276.46 meters squared. We're still meters squared. So I want you to go ahead, pause the video, and work on the problem on the right. Please note that it gives us you the diameter, not the radius. So you got to find the radius. So go ahead, pause the video, do that now. Alright, so here's the solution to that example. So go ahead, check your work with mine. And look at that, we got done 3 minutes earlier than we did before. Lucky you. So, video's done whenever you feel comfortable with the material.